Hey everybody, think back to Algebra 1. You guys learned a lot of shortcuts to go ahead and graph line equations, right? You learned a slope-intercept form, which is y equals mx plus b. You know that like when m is 3, you know what to do with it. You know when b is 4, for instance, you know what to do with it. So you learned all these shortcuts to do these lines, right? Well, today I'd like to start talking about what we're going to do a little bit more in Chapter 2, which is looking for shortcuts for other graphs, other than just, for instance, line graphs. So what I have here is 3 different equations, and we're going to look at each of these equations. But what you'll notice is they all are going to have something in common. Let's take a look at the first equation. So if I click on this first equation, you'll notice a very similar shape. In Algebra 1, we like to call these parabolas, right? And the one thing you'll notice about this is what is known as standard form in quadratics, another way of saying a graph that gives you a parabola. There'll be an x squared term, there's like this middle x term, and a number over here. It's the same type of equation you would throw into the quadratic formula, right? So if you take a look at it, it looks just like a normal parabola, opens upwards, what have you. Now the question is what can we gain from looking at the quadratic in this format? And what you'll notice right away is, for instance, there's an x squared. In fact, pretty much all these examples will have some kind of square in them. This one won't, but the square is kind of hidden. And the only thing I can maybe think of is if you take a look at the y-intercept here, it's 3. This happens to be a 3, so maybe that has something to do with it shortcut-wise. But other than that, if I look at any of these other main key points for the parabola, I'm not seeing like a 1 show up anywhere. I'm not seeing like a 2 or a -1 show up anywhere. I'm not seeing a 3 other than, you know, this 3 here show up. So this equation really has nothing to do with any of these other what are known as key points of this parabola. So I'm going to turn this one off for a second and let's turn on this next one. Okay, still parabola, right? But this time in blue. If I look at this one, a couple things I noticed about it is a little bit fewer numbers, right? There's just the 2 and the 1 compared to like some of this other stuff. There's still a square, right? But let's look at some of these key points again. I look at the y-intercept, right? 3. I don't see the 3 here. I look at these. I see a 1 and a 3. And to be honest, I'm not seeing like any of these numbers show up, so I don't know if there's really a shortcut here. But if you look at the vertex, what's really interesting here is at least the 2 and the -1 do show up in this equation. Here's a 2 and the 1. So maybe this type of equation gives us some kind of a shortcut or some kind of a tell into what is going on with this parabola. Let's look at this last mode. This is also a parabola. You'll notice that there's exponents in both of these. Now there's technically an exponent in these too. If you were to FOIL these out, you would get when you multiply the x times the x and x squared. So there goes your x squared part. But when I look at these two, right, it looks slightly different than some of these other ones previous to it. I can go ahead and look at these key points yet again. And you'll notice that one of the things I notice right away is like this thing we call the vertex. That doesn't show up in this at all. But I do notice that these 2 x-intercepts do, right? This 1 and this 3. And then you'll see a 1 and a 3 here. So I'm curious if that has maybe something to do with it. Don't know if you figured it out yet, but all 3 of these things, if I click them on at the same time, they're all the same graph, right? And I think you probably realized that by the second or third time that I kept graphing the same thing. Quadratics come in all shapes and sizes, as you'll find out over the next week or two, but there are really 3 formats that you'll see them in. So if we're going to start talking about learning shortcuts for parabolas or quadratics, we need to kind of get familiar with the different ways they will show up, right? And as I was going through, I was trying to look for links from what was going on in the graph, like either the x-intercepts of the graph, the y-intercept of the graph, or either what is known as the vertex of the graph. Like, is any of those numbers somehow showing up in the equation? Because if you remember the line equations, there were these numbers that would show up in the line equation that would tell you something about the graph, right? So that's really what I'm looking for, is like, is there any kind of shortcuts I can find? So we're really going to, over the next like week and a half, look for all the shortcuts possible in each of these formats. Now, probably the most common way to start with this is technically, we'll forget this one now, and we'll forget this one. But in reality, this is usually the most general one people will start with, and this is what is known as vertex form. They call this vertex form because if you take a look at the vertex of this, you'll notice that the 2 and the 1 show up, and there's a 2 and the 1 here. So what we're going to do is we're going to look at why vertex form works the way it does, and how to read an equation presented to us in vertex form. And hopefully by the end of this, you will have a better understanding, so you can just look at an equation like this and know exactly how it's going to show up on a piece of paper, which will kind of shortcut this whole like idea of having to plot points and all that other stuff. So eventually we won't have to investigate parabolas. We'll just have a good idea of what they look like, so we can get their domain and ranges and all the other stuff that we have to do last chapter. So let's go ahead and take a look at this. So what I'm going to do is I'm going to start off with what is known as a parent function. A parent function is an equation that's stripped down, nothing in it at all. There's nothing there other than just a variable and then the operation that gives the graph its shape. So the thing that gives a parabola its shape is the square, right? If I were to change anything about this, like for instance, change the 2 to a 3, you'll notice that it doesn't look like a parabola anymore. If I take away the 2 or exponent altogether, I'm back to linear equations, right? So the thing that gives this graph its shape is really that exponent next to the 2, okay? Or sorry, next to the x. So let us begin. So if you remember back to what vertex form looks like, right? There was a parenthesis around the x itself, and then there was some number out on the outside. What I'm going to do is I'm going to start playing around with this a little bit, and what I want you to do is kind of take a look on the graph and see if you can see what's going on with what I'm doing. So I'm going to start by just taking this x squared, and I'm going to start by adding a number to it. So let's add 3. When I do x squared plus 3, you'll notice that the shape of the graph pretty much stays the same, but you'll notice that the vertex moved from 0, 0, right, all the way up to 0, 3. So if you were to tell me, like, think back to geometry, how did I go from here to here? Now, a lot of you would say, well, I moved the graph up three spaces, right? The vertex was at 0, 0, and now I moved it up to, 0, 3. Similarly, if I went ahead and did something like this, x squared, we're back at 0, 0 for the vertex, right? If I went ahead and did minus, 4, you'll see now that the vertex is been shifted down from 0, 0 down to 0, -4. So it seems, or it appears, that if I were to take a value, say for example, we'll call it k, and just change the value of k, for instance, I'll do the slider. If it's a positive number, it seems to show up on the upper part of the x-axis, or up onto the y-axis. And if k seems to be minus, it shows up below the x-axis at whatever value k is. So in effect, as you guys can see, as I'm kind of shifting through these, the graph just shifts either up or down depending on whatever that k is. And the idea is that you think of it starting at 0, 0, we've just shifted it up from 0, 0 up to 5.33, right? Or whatever k value is, okay? So that's how I would think of k. Or this number on the outside, okay? Let's talk about the other thing that I remember from the other equation, is there was like these parentheses around x, and there was this number subtracted from it. In fact, it was something like this. Now, the one thing I noticed straight off the bat is that the parabola moved again. So it was at 0, 0, but this time it's at 2, 0, right? So in a sense, the graph was shifted from 0, 0 to 2, 0. So in a way, it was shifted 2 to the right, right? Just to check to make sure, if I made this a 3, yeah, it moved from 0, 0. So again, just x squared, that's 0, 0. But if I put minus 3 next to the x, you'll notice that the graph is shifted from 0 all the way over to 3, 0, right? Or a shift of 3 to the right. And then if I don't know, change this up a little bit, maybe make it a plus sign instead, you'll notice that the graph shows up over here as a negative 3, right? So again, if I were to just have it x squared, the graph's at 0, 0, or the vertex is at 0, 0, as you can see here. But if I just, go plus 3, the graph has shifted 3 to the left. Like all the points for the most part have shifted 3 to the left, but more importantly, I'm focused on the vertex here. It has shifted 3 to the left. Now the thing that I think is interesting is you'd think it would probably be counterintuitive, right? That plus 3, you'd think that'd be meaning that it would shift 3 to the right, not 3 to the left. But that is something that seems to be a little funky, so I might want to take note of that in my notes. But all in all, similar to K, right? If I go ahead and add a slider here, when it seems to be when x plus h, it goes to the left side, and then when it seems to be x minus h, or x minus a number, it seems to be going to the right. Either way, whether if I add or subtract, it seems to be having what is known as a horizontal shift to this. It's either moving it left or right, depending on whatever it is. So for instance, if I stop here, if it goes x minus 3.92, I've shifted the graph from 0, 0 over to 3.92 on the x-axis, right? Now, putting it all together, I could, for instance, like kind of do everything at once. I could have, for instance, an x plus 2 quantity squared and a plus 1. This guy gives it a shift 2 to the left, right? And then the guy on the outside gives it a shift up 1. So I can actually move it both left, right, and up or down at the same time. So I kind of have control over it left and right, and again, up and down. The only other thing I wanted to point out is another way that I can play with the graph a little bit, and we'll talk a little bit more about this a little bit more in class. But there's one other thing that you might see in these type of formats is a number out front. Now the number out front is being multiplied. So for instance, I'm going to put a 2 out here. What you'll notice right away is does that actually impact the vertex? And the answer is, and I'll take it off and then put it back on again. The answer is, so I put a 2 out front. You'll notice that again the vertex hasn't moved, it's still at negative 2, 1. But you'll notice what happened is that the arms kind of went up a little bit more. So what's happened is it almost kind of like stretch the arms up a little bit. So if I made this a 3, you'll notice, or a 4, or a 5, or a 6, these arms are kind of getting more and more stretched upwards. And this is going to be true for pretty much any number I did. The bigger the number, the more the arms will look like it's getting stretched. If I do smaller numbers, right, say for example, I don't know, 0.5, I can get it to stretch a little bit, kind of compressed. So really, it just kind of changes the curvature of this a little bit, it seems. But the thing I'm more interested about is what would happen if I have a number, say for example 2, but I make that number negative, okay? Now, again, this vertex really hasn't changed this entire time. It kind of was just kind of making the arms either spread apart or kind of get stretched. But the only thing I notice here is when this number out front is negative, that the parabola, instead of opening up, it seems to be opening down. Okay. And to be honest, this is really the only ways you can manipulate a parabola. You can change the curvature of it, which seems to be this number out front. You can change the shift of the vertex, which seems to be this number next to x on the inside of the parentheses. And then you can move a vertex up, down by changing this number here on the outside. So pretty much wrapping everything up, I have a few notes for you guys to jot down. So we're going to be focusing again on this parent function referring to as y equals x squared, and we're just doing things to x squared. What I would like you to pause the video real quick and jot down is this particular slide, okay? So this is normally what we like to call the general format for a vertex form. The A, the H, and the K are what are known as parameters. The X and the Y are the variables, but A, H, and K, they're parameters, and they each have a job to kind of giving you a shortcut on how to sketch these graphs as quickly as possible. So when you see A, for instance, being negative, the parabola opens downwards. If you see A and it's positive, the parabola opens up. These are just things I know right when I see this number out front. And again, this number will always be multiplied out front of the parenthesis in front of the X. And the bigger A is, the more vertically kind of stretched everything is. Secondly, H kind of controls what is known as the horizontal shift of this parabola. You can always usually think opposite here because again it kind of has a reverse effect than you'd think. So for instance, x minus 3 quantity squared, the graph has been shifted 3 to the right from 0, 0, or the vertex has gone from 0, 0 to negative 3 if you were to compare x squared to x minus 3 quantity squared. Similarly, y equals x plus 2 quantity squared, the graph has been shifted 2 to the left from the origin of just the plain old x squared parent function. And then lastly, k is a vertical shift. So if you see k to be positive, you're shifting up that many units. If you see negative k, you're shifting down that many units. Okay, so those will have numbers filled in for them, but these are kind of like the rules for each of those parameters. Okay, so what I thought would be a little bit helpful, and I know we're kind of running a little long, is to look at a few examples of sketching these to see if we kind of understand how to read the shortcuts. So if I take a look at this one, I want to jot down each of these numbers. So 2 would be my A. 2 is positive, so that means my graph is going to be open upwards. I see that I have an x minus 4 over here. I want to think this is my shift, and remember we're going to think opposite. So your brain is going to say it's a shift 4 to the left because of the whole minus thing, but really this means a 4 to the right shift from 0, 0. If it were just, x squared. And then this is going to tell me it's a shift 1. So if I were to sketch this graph, right, I would be going, again, I'm thinking of it as just a plain old y equals x squared, and I'm just going to be transforming this into its new location. So it says x minus 4, so that tells me it's going to be a shift 4 to the right. So it's going to go from boink, 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 boink. So that's going to move it to here. And I'm just going to kind of update it as I go along here. So here we go, x minus 4, boink. So you'll see that, again, that's shifted it to that point. I see the plus 1, so that's going to shift that up 1. So that's going to move it up to here, so at 4, 1. So I'm going to add the plus 1 and see if indeed that's what happens. It does. So this, just right off the bat, I can see the vertex is 4, 1 based on these numbers here. And then last but not least, my number out front is a 2. So I know that it's going to stay opening upwards, but the one thing I know about this is it's going to be a little bit more stretched than a traditional y equals x squared graph. Okay, so I've transformed it from x squared to its new format. And I guess I was able to kind of guess what was going to happen because I knew each of the numbers, right? So let's take a look at another one real quick. So in this one, we got y equals a negative. In this case, we'll think of it as a negative 1, x plus 2, quantity squared, and then minus 1. So a is going to be negative 1 or negative. So in this case, I know for sure it's going to be opening down. Another thing I know is that from 0, 0, the shift is going to be 2 to the left. But also I'm going to be shifting it down 1. So I'm actually going to, before I even graph this, I'm just going to do it kind of basically based on what it tells me here and see if I can just predict it without doing it step by step. So it again is telling me shift 2 to the left because I'm thinking opposite here. And then down 1 from 0, 0. So usually a parabola starts at 0, 0. If nothing's done to it, I'm going to move it 2 to the left and then down 1. So it's going to be right here at negative 2, negative 1 is going to be where the vertex is. And then because that whole A was negative out front, I know that that parabola is going to open downwards. Okay, so I'm going to copy in what that parabola was. So it was negative x minus 2 quantity squared, and then it was minus 1. Or, my bad, sorry, x plus 2. I was like, it was shifted totally the wrong way. And then, like I said, it showed up where I knew it was going to show up, and it also is opening downwards. Again, I just want to make sure you drive home that plus or that minus is completely opposite the way your brain will think of it. So again, an x plus 2 means a shift 2 to the left. All right. Finally, last but not least, this last one, okay? So you'll notice here there is no a value. So actually when that happens, then you think of it as just a 1, okay? Because 1 times anything is itself. So you can think of that as a 1. And if it's positive, really just means this graph is going to be opening upwards. We have a shift here. Let me have you guess. So is it right or left? And if you guessed right, you're absolutely correct. So this is going to be a shift to the right 3. And then there's no K out here. So in this case, we're going to assume that means that there is 0 shift, right? Nothing, right? Because if it was a 1, for instance, you'd have to put the 1 there. So there's going to be no shift up. Okay, so it's going to be opening upwards because it's positive out front, but we are going to be shifting the parabola 3 to the right. Okay, so again, thinking from 0, 0, I'm going to be shifting the parabola 3 to the right. So 1, 2, 3. So the vertex is going to be here, and then my bet is that the parabola is going to be opening upwards. So just to check that, I got y equals x minus 3, 1 squared. And just as I predicted, I have my point here, and I have my parabola opening upwards. So I am fairly confident that I know how that graph was going to look before it even showed up on the screen, right? So that's pretty much what I wanted to show you guys. I know that this is at this point 20-some minutes long, and it's a little bit longer, but I promise you this, once you kind of get the swing of this, the good news is that a lot of these other equations that we'll be learning, they all kind of work, and their behaviors are all about the same. So if you learn one, it's kind of an uphill battle the first time, but the other ones become a lot easier because they have similar rules to them. So this is again known as vertex form. You guys will have a quick quiz where you're going to check to see how you're doing understanding wise on this, and hopefully you guys are cool. Now when we meet in class next time, you guys can ask questions because I'm sure you'll have a few, but we'll practice a little bit more of this in class to see how you guys are doing. Okay, so you guys have a wonderful day. I'll talk to you later. Bye.